we'll have a couple days with this. You did this some in Algebra 2, I believe, but again, we're gonna get a little more complex. We'll go into some more challenging problems than you probably saw then. So this was your strategy for solving exponentials last year. We can use this property that if a to the u equals a to the b, then u equals b. In other words, if we have exponential equations with the same base on each side, that means the exponents have to be equal to each other. So our goal is going to be to try to simplify the problem so we can get the same base on each side, and then we can drop the base and set those exponents equal. Let's look at some problems. So if I said 3 to the x plus 1 equals 81. You are not that sneaky.
Me, I'm not trying to be sneaky. I just pulled it up.
Tapped Ben on the shoulder and then looked away so Ben could be the guilty one.
I was looking at the board, Miss Thacker. I pulled up my animation.
I figured.
And before that, I finished my website.
Okay, so if I'm trying to write these with the same base, I would like to rewrite 81 as 3 to some power. 3 to what power equals 81? 4. So now we have the same base on each side, which means these exponents should be equal to one another. So x plus 1 equals 4, subtract 1, and x equals 3. You can always check these. If I plug this in, we get 3 to the 3 plus 1, so 3 to the 4th equals 81. It works.
I remember this now. Yeah.
So 16 is 2 to the 4th. And then x is
84. You put 1 and I was like, what?
so far so good.
Yeah.
What if I gave you? Do we want a hard one?
You're gonna give
Yeah,
it to
of
us.
course. Oh.
All right.
Well, we just gotta make them all the same base.
Yes. Can you take 4 times 2 when they have those exponents?
No.
No. But my property only works if I only have the base written once on each side. So I need to rewrite these. What could I change my 4 to?
2 squared.
And that was 2 to the x. Times 2 to the x squared equals, okay, 16. What could I make that? 2 to the, okay.
Squared, right?
Mm-hmm. Power to a power, what do you do with those exponents?
Multiply.
So we have 2 to the 2x times 2 to the x squared equals 2 to the x. We still can't use our property yet, but if you have these multiplied, what do you do with your exponents? So this would be 2 to the x squared plus 2x equals 2 to the 8.
Or could we not just like go ahead and drop it down, x squared plus 2x equals 8?
You have to make sure you add them.
So that's like a, okay.
So now we have the base written once on each side, so now we can drop it and set the exponents equal to one another. Quadratics, we always set equal to 0. What multiplies to -8 and adds to +2? So we get x to be
-4 cos
And then, you know, you can certainly check these if you're not sure, plugging them into the calculator. We haven't done anything that should give us solutions that don't work, so it's not like a mandated, you must check because you're going to get extra solutions type problem. But it doesn't take long to plug these in, just to quickly double check on test or quiz. So that one's good? So, what's my common base here? E. So I can't do anything with E, so we have to keep that. So I have E to the x squared equals E to the 3x. What would I do with 1 over E squared?
You multiply it by, oh yeah.
You could multiply the E squared over, or you could realize that if you want to change floors, you just change the sign, so it becomes a negative 2 power.
Yeah, that's right.
So then, if these are multiplied, what do we do with their exponents? So now we have 1e on each side, so we can set our exponents equal to one another. So quadratic, we set it equal to 0. So what would this factor in?
-2, -1.
So x equals
2, 1.
Thank you. Thank you. Goodness. Look at that. This morning I had all these people tell me how their allergies were so bad, and I didn't think mine had started yet, but maybe they have.
When it happened.
Yeah. Just all of a sudden. What's my common base going to be on this? 5. How would I write the cube root of 5? How do you write 1 over 5? Since there were already exponents there, power to a power, we multiply. So we get 5 to the negative 1/3 x equals 5 to the negative x minus 2. So now let's have our exponents equal. Add our x over So then, what do you get for x? maybe 3 more, and then I'm done.
Would it not be?
Negative 3.
No, yeah, okay.
Alright, so common base is what?
Oh, 2.
So I have just a plain 2, or I could write that as 2 to the first. 4 to the 3x. So that would be 2 squared to the 3x. How would you do 1 over 64?
To the, oh yeah.
So we get 2 to the first times 2 to the 6x equals 2 to the negative 6. Multiplying those together means add the exponents. Divide and we get negative. I don't know. Sorry. I was just going with it. How about negative 7/6 for the final answer? Any issues at all? Alright. Can you figure out what I would do here?
Times it all by 0.
Oh, well, you can't do that.
Yes, you can. Because then it all equals 0.
Yeah, you lose your problem. We need a common base, right? Can you change a base of 5?
Yes.
5 doesn't break down to anything else. So I have to rewrite 1 as a base of 5. So 5 to what power equals 1?
0. That's stupid.
That's stupid.
Wait.
Anything to the 0 power is 1.
I'm gonna question that. So if you multiply and divide by everything and it's 0, then why is it
Well, it's only you
is 0 a number? I saw this episode of Sheldon.
0 is a number. It represents the absence of something. I'm gonna have a big philosophical debate here. Alright, ready for the last one?
Yeah.
I don't know if they're going to go into another discussion.
It could.
1.5.
To the 0 power.
Yeah.
Yeah, we just take everything to the 0 power.
Only works with a 1, because anything to the 0 power is 1.
Then it would work. 1 equals 1. Seriously, there's like it's like a cheat code to math.
Yeah.
Then you had to check every single number.
So, what could I do? I've got to try to get a common base. Does anyone have an idea?
No, not at all.
What'd you do?
Yeah. So 1.5 is 3 halves as a fraction, and you're gonna take 27/8 and see how you can get down to 3 halves, which would be if you take 1.53 to the 3rd power.
So, 1.5 is 3 over 2.
Right off press.
So, we need to try to decide 27 over 8. I want to write that as 3 over 2 to some power. 3 to what power equals 27? 3. And 2 to the 3rd is 8. So this is 3 halves to the x plus 1 equals 3 halves to the 3x. So x plus 1 equals 3x. So 1 is 2x and x is 1. Alright. that's the end of today. There is a handout post on Classroom. It's probably a few more questions than I usually give you, but they're short. There's some that require very, very little work, and you have quite a bit of